4 essential software design principles. My journey was solid. Welcome back to StartupHakk. With 25 years of development experience here at StartupHakk, we turn beginners into full-stack developers in as little as 3 months. Today I want to share some crucial software design principles I've learned over the years, specifically focusing on the SOLID principles. Now, SOLID is an acronym, and we're going to talk about those. These principles are foundational for creating robust and maintainable software. Let's break them down into 5 key points, each illustrating an essential aspect of software design. So number 1, single responsibility principle, or SRP. The single responsibility principle states that a class should have only one reason to change. This means that each class should only have one job or responsibility. Following SRP makes your code more modular and easier to understand. It also simplifies maintenance, as changes in one part of the code are less likely to impact other parts of the code. Number 2, open-close principle, or OCP. According to the open-close principle, software entities should be open for extension but closed for modification. This encourages designing modules that allow behavior to be extended without modifying existing code. By adhering to OCP, you can enhance your application's functionality while preserving the integrity of existing code. This principle is key to achieving a flexible and resilient code base. Number 3, Lisov substitution principle, or LSP. The Lisov substitution principle ensures that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Essentially, derived classes must be substitutable for their base classes. This principle promotes the use of polymorphism and ensures that a derived class can stand in for its parent class. Following LSP helps in creating more reliable and maintainable object-oriented systems. Number 4, interface segregation principle, or ISP. The interface segregation principle advises that no client should be forced to depend on methods it does not use. This means creating specific interfaces for different clients rather than a single general-purpose interface. Adhering to ISP results in more decoupling and cohesive code. It allows developers to implement changes more easily and reduce the impact on unrelated parts of the system. Number 5, dependency inversion principle, or DIP. The dependency inversion principle states that high-level modules should not depend on low-level modules, but should depend on abstractions. This principle aims to decouple software modules, making them more interchangeable and easier to manage. By following DIP, you create a more flexible and resilient architecture. It encourages the use of interfaces or abstract classes to invert dependencies, promoting loose coupling between components. Now, what are your thoughts? Do you agree? Do you disagree? I love to have a good discussion, so make sure to leave the comments down below and make sure to like and subscribe. Here at StartupHakk, we love training software developers. With my 25 years of development experience, we take people with zero experience and help them train them to be ready to start as full-stack software developers in as little as 3 months. So make sure to check out the link down below or go to startuphakk.com today.